Hello everybody, my name is Craig Bennett, and today I'm going to get into a video on how the internet works. Now this is going to be a simplified overview of things. If you want a little bit more exacts on particulars, I actually do have videos, enterprise level, home level, cybersecurity, all that. So feel free to check that out. Got tons of videos on that. But as far as this goes, we're going to be just using Paint and enjoying ourselves and whatever, and hopefully you learned something. If not, then whatever. So first things first is you're going to need to have a reason to go on the internet at all. That's kind of a given. So you're going to need to have a server. And what a server is basically just a computer. Your computer that you're using now, whether it's a phone, tablet, whatever, as long as you have the ability to do it. So your desktop, laptop definitely should be able to, same thing if your Raspberry Pi, your phone, tablet maybe. But basically you can actually make a website, host it on the actual device, and as long as some Joe Blow on the internet has the ability, like you actually allow that with your firewall and whatever, they can actually remotely look at your website and interact with it or do whatever. So you can legitimately turn your own system into a server. All it is a computer that serves. Now the difference between this and stuff you see at Google or whatever is dedicated servers. So your server, phone, tablet, whatever, it's a generalized computer, which just basically means that it's a jack of all trades and master of none, as the saying goes. Whereas a dedicated server does nothing else but be a server. A lot of times they don't even have a user interface. It's all code. So just note that it's very, very, very dedicated to one task, and that's it. Sometimes you can do multiple tasks, but I mean it's very limited, and that's for a good reason. So from there, note that you could have a localized internet, and you'll see this in some research places, corporations, and other things. And let's just say, for example, if you're logging into your workplace through some type of VPN, midway somewhere you're going to have some type of firewall, whatever. But once you hit the actual thing, it's going to, and let's just assume that there's multiple servers. All this can legitimately be on one server in today's world. But you'll have your email server, your database server, your whatever and whatever. But basically you can actually have everything in one small environment. And if you want to remote into it, then you can use some type of VPN, virtual private network, to get into it, which is what most workplaces use. Now, and that's why that you can get access to whatever you need to be versus some Joe Blow on the internet having access. It has to go through a very exact thing that's secured. But let's just say, for example, if you are a Joe Blow on that company, whatever, you can actually legitimately connect to that overall system and connect to all these things, and you can have an internal website. Some places definitely have this, and it's kind of neat, but they also tend to be underdeveloped. Now, for the wider world, you're going to need to have a internet service provider, and this is just basically a company that pushes your stuff out to the internet, to the overall internet, or brings the internet to you. So in this case, internet service providers, they're going to note down a few things. First off, your IP address. And I'm not going to get into too much detail into this, but let's just say that you want to go to google.com. Well, instead of typing the IP address, which might be something as simple as 1.22 blah 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 blah, you're typing in google.com, and that's good enough. The problem is how do you get, even if you do type in here, how do you get here? And that's something, the internet doesn't have eyes. It doesn't know exactly where hardware is. So it has to figure out all this stuff on its own with timing and whatnot. So what you have throughout the world and throughout, even ISPs, have this, and even companies can have a DNS server, and private households too. But the ones that's being used is out there in wider world, meant for this exact task, is dedicated DNS, and also ISPs. But basically, these are phone books of the internet. So whenever you type in, say, google.com or whatever, it looks at one of these, and it figures out what is the IP address that's associated to it, and it sends your traffic to where it needs to go and from where it needs to go. But let's say that this is a brand new website, and you are sitting with your ISP and your computer. How do you get here? So first things first is, when all this stuff is established, your ISP should send out to the DNS servers the information. Now, it's probably not going to reach them all, so what happens from there is you'll see the DNS servers blast out the information to the other DNS servers, and it tends to populate within 2 hours worldwide. Anywhere should have no problem at finding the actual address. Now, let's just say, for example, it's a brand new one. It didn't have time. It didn't get to all the DNS servers. You type in the address, and your ISP is like, okay, I don't know where the IP address is. I don't know where it's sending traffic. So what happens is it goes to a DNS server, says, hey, do you know where the IP address is to that? And the DNS server, if it says no, if it doesn't know, then the DNS server will look out and try to figure it out. If it cannot find it, then you'll do just a timeout, and then it'll go down the chain, and your computer will say, oh, well, it's just timed out. So that's where you'll get those errors. But for the most part, once it gets to this point, the DNS server looks for it, and when it finds it, then it will populate its own stuff and populate that, and then it will do the rest of what the internet needs to be doing. So let's assume that everything's good on that front, and everything's whatever. What you're going to see next is something like this. This is command prompt. You can type into Windows CMD, and you can open that up. But you can do a trace RT command, and as you see right here, and note that I'm just using this image because you will see personal information like your local IP address. I don't really care to show that. Don't really care to do the extra work because it's just for fun. But your first few hops is probably going to be your local, so note that it's going to be worthless. But after a certain point, it's going to hit your actual ISP. Notes that it doesn't always look like this. You might see something. Let's see if I can find one that actually has like Sudden Link or something like that, or Comcast or one of the others. But basically, sometimes you'll see something like Comcast or Sudden Link or something else, and from there you can actually see when it hits an actual server. But you can see that the person puts in Cisco.com, get the local stuff, so their actual modem, their router, whatever. Then it hits the actual local. Then going from here down to, it looks like this point, it hits an actual Cisco system. And then for the Cisco.com, just note how I'm figuring it, Cisco, it goes all the way down to this point to figure out how to even get to Cisco.com. So just note that it can take quite a number of hops. Like it took 20 different places for a package, for a bit of data to go through to just reach this. And this is with the internet knowing where this address is, or at least how to get there. So that should be noted into itself, that whenever you send information out, the information is going through many different layers, and if any of these layers are compromised and your information is out there, like if you're going to a HTTP address, which honestly in this day and age you really shouldn't, your system should automatically be denying that at this point. But if you are going to that, then all these layers should be able to read everything that you're looking at or whatever. And even with HTTPS, if it wanted to, it can grab the data, and at some later point it can try to figure it out and do whatever it needs to break into the actual data itself. So it should be noted that it's not as straight from point A to point B. You're literally talking about 20 different points. Yeah, of course, the first few is your very much local, but it quickly goes outside of local and goes into an actual uncontrolled space. And note that you can have over 30 hops, but just note that for TraceRT it shows only up to 30 hops. Now real quick, let's just assume that you're wondering about Starlink or whatever, and let's just say that that's a satellite. Basically what happens is let's try to draw everything else. The ISP, Starlink station, whatever, it broadcasts out to and from the actual satellites. Basically, it's grabbing information from your system, your request and whatnot, and also it's sending information to your system. So say for example you're watching this video, it's over Starlink stuff. Obviously, the video didn't get created anywhere other than down here. It has to be somehow connected to the Starlink systems. It broadcasts out to the actual Starlink satellites, and from there it broadcasts it down. Now, when it broadcasts out to Starlink satellites, let's imagine this circle is Earth, and then you got all these little satellites all over the place. One of the things that could happen, I don't know if 100% this does happen or not, but you can have a ground station that sends out to a given satellite, and from there it could send to other satellites until it needs to go down to a given point. This is actually how some internet, satellite-based internet works, and you'll see in some stuff like military communication and other things, and especially now that we're getting into space age stuff and going back to the moon and stuff like that, you're probably going to see a lot more of that for obvious reasons. But this is also another way. It's just more or less, instead of you having a server here, a customer over here, a ISP, a bunch of little hops, whatever, and a thing just having to figure out a way on land, it's just going through the actual sky versus on land. Same difference, but this tends to be more effective, especially continent to continent. So instead of someone from the UK trying to access a web server that is Silicon Valley, for example, and it's going through actual hardline cables, it's more effective going through satellites, because you don't have to run a cable through the ocean, because satellites. Anyways, hopefully this makes sense, and hope that whoever joins us, and I'll see you next video. Hope you have a great day.